There are projects that don't make it. There are projects that never finish. What happens now when your requirements change completely and you can't have it running all the time?
Right. Yeah, you probably don't want to do that.
And it's like you wrote an app that does XYZ. Now you need it to do ZYX. So it probably does work. Just the learning about it got me excited about computers.
Right, because education is something that they can never take away from you.
So then I was like, maybe I can do something with computers for a living. I didn't know what it was going to be or, exactly what I was going to do, but I knew I liked computers enough to work with it.
Welcome to the Might Not Be So Good podcast. Today we are joined by Gabe Tapizquent. Gabe is a senior software engineer working at Google right now with the ads division. We typically have Sky here, who's my co-host AI, but unfortunately for some personal reasons, she could not be here today. But she did send a couple of questions that we're going to be going over as well. And, things that I find very interesting. How are you doing today, Gabe?
Sounds good. I'm good. I'm happy to be here. Happy to be talking to you today. So yeah, excited.
Thank you. It's definitely an honor to have you here. So you've worked at some of the biggest companies in tech in the world right now. You've had an amazing accomplishment, even now working at Google as a senior engineer and being promoted within just a few months. That not only shows great accomplishments, but it also shows a lot of dedication and skill set that you have to put into that. But how about we take it back to the beginning? I grew up with you back in Venezuela, but most of your tech career has been outside of our family bowl, right?
Yeah.
So
for sure.
Talk to me about that. How do you get into technology, and when did you know that that's what you wanted to do?
Yeah, I mean it definitely wasn't a straight up thing that I knew I wanted to be a software engineer. I knew that I wanted to do software or technology in general. I think for me, our stepfather was into like electronics and stuff.
Right.
So I kind of got involved in that. I liked computers, so I mainly liked to use computers and like building my own machines and stuff. Like I was excited about upgrading RAM and all that and learning about it mainly because I never actually built a computer, but just the learning about it got me excited about computers. So then I was like, all right, like maybe I can do something with computers for a living. I didn't know what it was going to be or, exactly what I was going to do, but I knew I liked computers enough to work with them, right? To do something work related with computers. And then we moved to the US and I was already 18, 19 years old when I started college, started doing some basic courses and wasn't really introduced to a lot of technology courses per se because I was doing community college, so it was just like basic general courses, math, physics, and whatnot. But I kept going. I had an interest. I wanted to learn more. And it wasn't until I got to university at the University of Florida when I actually started to get exposed to those proper engineering courses, right? I got a degree in computer engineering, so my areas of study were a bit more focused to on hardware. So I had a lot more courses on hardware, like circuits, computer architecture, and so on, microcontrollers, digital logic. But then as time went on, I became more interested in software. And then I guess it all really started with first taking CS1, like programming one, and basically liking how quick of a feedback loop I had when I was typing hello world. It was Java, so system print whatever out hello world, and then running my program and seeing it print to the console. Like that was super satisfying, and getting that quick feedback loop that could make a change, edit it, and then get it back and basically see the effects of what I was doing right there and then, right? That was very satisfying. And I think to this day, it is very satisfying. It's one of the reasons why I love doing what I do.
That's very exciting. And it's true because it's the difference between working with hardware and working with software, right? Like working with hardware, I'm assuming involves a whole different other side that we're not very exposed to on a normal basis.
Yeah. I mean, I didn't get to work professionally per se with hardware, but again, I did computer engineering. So towards the last couple of semesters, of course, just you're being exposed to low level stuff like actual circuits. So you're doing math and circuits, you're prototyping, and at least at the University of Florida is very hands on. So you learn about something, you go to the lab and you build it, and you blow things up on a proto board and on a breadboard and test things. So you start learning from there, right? Then you jump into like, okay, you already know about circuits, you know about the low level stuff, DC, AC. And then it's like, all right, now we're going to learn about digital logic. And, what is digital logic? This is how computers became to be, right? Like, how do we turn electricity, low voltage into logic, right? Into something
Mhm.
that can make decisions based on inputs, right? Because that's what a computer is at the end of the day, right? Like you have an input, you run it through some gates that determine the logic of what's going to happen, and you get some
Mhm.
output. So yeah, working with hardware is a bit different. And then moving on to my like senior design projects. Of course, for those who are not familiar with engineering, like generally to graduate, you need to complete a capstone project, which is some project where you design and build something from scratch, right? So
Right.
everything that whatever it is you're building will be, you have to design and build. So I was working with my buddy. It was a two people project, and we built a little autonomous car. And though of course we didn't build the housing, the framing, because we were not mechanical engineers, but we built all the electronics, as far as designing the PCB, the printed circuit board, with all the inputs and outputs. Because of course it was an autonomous car. We had sensors, we had distance sensors, we had sensors giving us feedback for the motors, and several things that were on board. So designing the printed circuit board, prototyping it, then sending it out to be printed and getting it on and actually soldering it, and then debugging the hardware. So it's amazing, right? But there's still a big component of software even there, right? Because you have your bare computer that has a lot of inputs and things, and you have a tiny microcontroller, and then how you structure your software is going to matter, right? Because you are processing all these inputs that are coming from multiple sensors. You
Right.
want to react to them quick enough so that you can make decisions on them. But that means that you have to time share your processor, right? So
Right.
when you're working with like high level programming languages or a full blown computer, you generally don't think about things like, oh, how much memory is this going to be using? Unless it becomes a problem, right? Like you're
Right.
usually not concerned about memory usage, or you're not, unless you're working on something that's high performance, you're not really concerned about thread management too much, or whether something's going to take a bit longer than something else.
It's
You
not the
know,
common thing in
it's not
software.
the common thing, right? Like unless you're optimizing or you're working on a high throughput or high performance type system,
Hmm.
you're not really worried about that. But in microcontrollers, you have a little CPU that's running at like 32 megahertz. So that's your clock rate with, I don't know, if anything 100 megabytes of RAM. And those were like beefed up ones. We
It,
have.
in comparison to that, to your phone, is that a lot? Or, for people that might not be familiar
Oh,
with
yes.
what that
So
means, right?
so no, like my phone is, I don't know, thousand, a million times more
Wow.
powerful than that, right? Like we're talking about the type of computer that you'd find in like your microwave, right? So this is usually an example that when people ask me like, oh, what's an embedded system? Like what makes it, embedded, right?
Hmm.
So it's like it has a computer, right? It makes decisions, but it's not a general purpose computer, right? It's not a computer that you would run other programs on. It's very
Right.
purposed, designed, and tailored. And the software there usually called firmware because it's usually long lived. New appliances and whatnot do have software updates and all that, but firmware is very delicate, right? Like if you mess up a firmware update, then chances are your device could become damaged, breaks, right?
Oh, wow.
Uh,
Yeah, you probably don't want to do that.
yeah, so embedded systems, very very purpose driven, very specific, computer that only does a couple of things, right? Like think of your microwave. It has to handle input from, I don't know, 15 buttons which you press, and
Right.
then those buttons are driving a state machine, which is, a little thing that tells it where it is. Like, oh, am I in the heating cycle? Yes, no. Am I stopped? Am I about to start? And
Right.
based on that, what buttons you press, it's gonna turn on something else, right? Like, oh, they selected minute and 30 seconds, they hit start. All right, I know that I'm gonna run for a minute and 30 seconds, so I start a timer for that long, and then I turn on another pin, an output that
Hmm.
drives the magnetron, right? That drives the spinning disk, that drives something else on the microwave.
Right.
And that's all that computer does. Like that's its whole functionality. So you don't need a lot of hardware, you don't need a lot of computing power for that, because most of the time the actual computer is actually sleeping. right? Like
Okay.
you're only processing input, so you get woken up when you have input. You make a decision real quick, and you start something else, right? And that's it. Like that's all what an embedded system is, right? Simple ones. There are very complex ones, but yeah.
In simple terms. So that also allows you to have things that don't require a lot of battery as well, or maybe things that you can have on like new alarm systems and whatnot.
Correct. Yeah. So there are these things called interrupts on computers, and basically an interrupt is you have your processor that's running instructions, and it should tell people like, oh, how does a processor work? I tell them think about a spreadsheet, right? When you read a spreadsheet, you're reading from top to bottom most of the time, and the computer does the same thing, right? So each row on a spreadsheet is a memory address, and the computer is going and reading from each row, right? And each row is gonna be an instruction. An instruction is just something that tells the computer what to do, right? It's gonna tell it to add two numbers, to move things from one place in memory to the next, to increase a counter, decrease it, or whatever it is, right? That's what the computer is doing. That's done by the main processor. But then there is a subsystem that handles interrupts, and an interrupt is a signal that has a higher priority that can basically preempt or stop the processor and have it handle something else, right?
Right.
So it's like you're doing this, and your kid comes and pokes you like, Mom, I want attention. You have to go, pay attention to them and then go back to work. Like that's what an interrupt
Or
is.
bad things can happen.
Or bad things can happen. Exactly.
Yes.
So generally interrupts are reserved, for important things, but you can also rely on interrupts for things like button presses, right? So you put your processor in a very, very low power mode where it's barely using power. And then it relies on interrupts to be woken up. So the interrupt system is always running, but the processor itself is not spinning cycles. It's not running. It's not really doing anything. Right. So the moment a button gets pressed, the processor gets woken up, and then it can run a little program, do something, and go back to sleep. So that's how, for example, like battery powered cameras would work, and little things that are battery powered, because you can't have it running all the time,
right?
Or your battery's not gonna last at all, right?
Right. Yeah, for certain devices, you don't have the luxury that you have with a phone that you can charge it, or you have a big battery that you can use, right?
Yeah, and phones have huge batteries. Like when you think about it, you have a display and then a huge battery about the size of the display in the back. And well, even phones are optimized for battery usage, right? Because the longer your battery lasts, the better user experience that you have.
Correct, of course.
Also, just recapping, like we've talked about all these devices, right? Like embedded systems, general purpose computers, and those are just a couple of applications of computer engineering or computer science or software engineering. And there's so much breadth and there's so much depth on whatever it is that you would want to do. And tying it back, like as I was in college and I started to interact with people, which I found everyone brilliant because they were very good engineers. They were very passionate about what they were doing. And I met a lot of people in this place in school called the Machine Intelligence Lab, which was a robotics place. I also got involved in robotics for a little bit. And that was very exciting just to learn about all the possible things that you can do with computers, right? All the applications and things that are out there that you don't even think about, right? Your fridge has a computer, your dishwasher has a computer, your microwave has a computer, your car has 50 computers.
And even more now with Teslas and whatnot, right?
So it's like, your watch has a computer if it's a digital watch.
Right.
Your phone is an incredibly powerful computer. The traffic lights have a computer driving them. So in this digital, and modern world that we live in, everything or many of the things that we interact with are driven by computers.
That's very interesting, because even we opened this, even though you have so much experience and your whole, I guess, passion since you started having hardware, somehow you ended up at Google, which mostly works, or your work mostly comprises of software, right?
Right.
Why do you think that is? Besides the fact of the fast feedback, why do you think that is right now? Why not hardware, or why not?
So I think in my case, I found a lot of freedom in software. Like in software engineering, there are these principles of like write software that can easily be extended without it necessarily being modified. Meaning, that might be a bit technical into software engineering terms, but it's like, write software that you can change easily, right? Like when you're trying to make a decision, the decision is going to be based on do something that makes it easier to change in the future, right? Because software is malleable. And this is the perception of both software engineers and of like management, right? Like,
Right.
you have a system, you can add features, you can remove things, you can integrate it with other systems. So that flexibility of being able to do that, I think kept me going to software. It's like I compare it to, for example, like my wife's work, where she's a civil engineer and she works in construction, right?
Okay.
She is very dedicated and amazing at her job, and she'll be very involved in every aspect of the project because she works as a project manager. But usually she'll have to wait months to see the results of her work, right? Like she's planning, designing, making calls, organizing. There's a lot of logistics, there's a lot of things, but it's not until the building is completely built that you see the results of what you did, right? And that could take years for software for
You might not even see it.
yeah, maybe if you leave the company or whatever, you might not even see the end result of what you've been working for years. Of course, that's not to say that the same is not true for software. Like there are projects that don't make it live. There are projects that never finish. This is true. But again, that feedback cycle is there. And in professional software engineering, you have a lot of tests. You have a lot of validation. So you validate the parts of the system of the product that you've built as you go. So you always have that quick feedback loop on the thing that you're building.
Right. And I guess it taps into that like reward system, right? Like it's like I write something, I see it right away. It's that experience that makes it. And talking about experience and all of these things that you've worked on, you've had these experiences in multiple companies. And not every company works the same, right? We'll get to Google in a second, but can you walk me a bit through what it is like working at these big tech companies and maybe what experiences or takeaways you've had from each of those? And
sure. So I'll just say to start with, it's none of what I'm saying is a characterization of any company or the voice of any company. This is my personal opinion from having worked at places. So big companies and small companies, I think that there's definitely variation in the things that companies put focus on, right? As far as employees go. So worked at a lot of places, and when I was going to college, I did several internships because I was like doing an internship and I would save up enough money to pay for the next semester.
right.
So while I was in college, I worked at GE and I worked at Intel and I worked at Ultimate Software, which is now UKG. So those companies themselves are pretty big, right? Like GE, I was in the appliances division, but GE, I think everyone's heard of GE.
General Electric, of
General
course.
Electric, it's a bit of an older school company, right? Like when you think about tech, you probably don't think about GE.
It's the OG tech, though.
Yeah, exactly. It's like old school, like they were huge at some point and developed many things, and they still do. Like there's G Digital, there's also the aviation side, which they make jet turbines. There's appliances. There's many branches of G still.
Right.
That was like the first job that I had, which also drew me into software engineering. And the reason that drew me into software engineering is because I found amazing software engineering practices at GE, right? Like you wouldn't think of, GE, like you don't think about GE as a big tech company, but it was amazing working there. They had great people that cared a lot about their trade, that cared a lot about the software that they were writing, that cared a lot about good engineering practices, that really wanted to build something that not only worked, but was extensible, was performant, looked good, right? Like one thing that I always tell people is like, when you're writing code, remember that you're writing code for other people to read.
Right.
For other people and for you to read. Because at the end of the day, you can give any code that compiles and it's logically correct and give it to the compiler and it'll run, right? Like the computer will understand it. So when you write code, you're not writing code for the computer per se, right? Like, although that's the ultimate goal, right? You want to write something in English that the computer can understand, but you're writing code for other people to read because that's the bread and butter, right? Like you're engineering solutions that have to be extensible, that have to be maintained over time, that have to be you have to be able to add features and so on. I interned at GE even before I had taken any proper software engineering courses. So I had taken programming 1 and programming 2 maybe, but I hadn't really taken software engineering practices, right? Like what is the job of a software engineer? Like what
Right.
when you get to work, what are the tools or the general type of tools that you'll be using? What is your work, your day to day look like, right? Like that I didn't know. So I get to GE and I was introduced to all these concepts, the solid principles for programming, test driven development, object oriented programming, and all these things. And what was really interesting is that they were doing all these things to develop C code that runs in microcontrollers. So if you think about it, C is not even an object oriented language.
Right.
And they built all of these abstractions and all these cool things that made the code very readable. And you would write your code as if you were writing object oriented programming, right? And they even had like dependency injection. It was pretty cool. Like I learned about all these things that I didn't know about before I even learned about them in classes or in other places that program with higher level programming languages. So that was definitely very interesting. And I think that GE is one of the places where I learned the most at as far as good software engineering practices early on in my career, really, when I was still in college and interning. Then I went to Intel. I interned, I did a couple of rotations at GE, but then I also went to Intel. At Intel, I was not doing software, right? Like I was still in college. I was trying to understand what other jobs were available for technical people. And I actually joined the technical marketing engineering team in the storage group at Intel. So working with SSDs, right? The SSD
Okay,
team.
okay. So like hard drives, right?
Hard drives, yeah.
Like
Hard,
to
hard
store
drives.
how we store data in our computers. Per se.
Exactly. So how we store data. And yeah, I was with the technical marketing engineering team. And what they basically do is they build like proof of concepts or use cases for products, right? Like let's say I'm trying to sell a pencil. I'm going to go and find 100 use cases for this pencil and then show you how useful this pencil is, right?
Right.
And that's a selling strategy, right? Because I can go and show you, look at all the things that you can do with the pencil, and it works great. Now I give you ideas of how you can use the pencil. So that's what I did there. I also wrote software, of course, because we were putting together prototypes and testing things and automating and building cool things for the purpose of showcasing hard drives or solid state drives. And that was interesting, but I wanted to do more software. Like I liked the job, I liked the place. Intel is also an amazing company. I was exposed to a bunch of incredibly smart people, but I wanted to do software. Like I wanted to do more software. Then after that, I interned at UKG, Ultimate Software.
One more software than Ultimate Software, right?
Yeah, exactly. Ultimate Software. And I also found very good practices at Ultimate, right? Like they also were doing test-driven development, or there were a lot of tests. There was CI/CD, there was automation. I found really really good things at Ultimate as well. So after a couple of internships, that's when I think I finally ended up taking what UF is taught as software engineering, which is one class that basically teaches you the best practices of the job, the profession, the trade of software engineering, and then I was able to cross-check that with what I had seen at the places that I had worked, and basically everything clicked, right? It's like, oh, okay, this is why we do these things, and they were taught in theory at school and explaining the reason behind things and how it evolved and how it came to be and all these things. And I could cross check with what we did at the actual job, right? It's like, oh, okay, so it matches, like what I'm being taught is actually what
Makes
I'm
sense.
doing outside of school.
Which is different from having, right, like as you continue mentioning, software engineering rather than just programming, right? Because you can write code that's impossible to maintain or even upgrade at any point, and that's where these practices come into play.
Yeah, I sometimes go and like read some of my old code that might still be on GitHub or like on an old computer of mine, and oh gosh. And there's nothing wrong with that, right? Because we all have to start somewhere and we all have to learn. There's this funny story when I was at school at the machine intelligence lab. I never personally met the guy.
Okay.
But this was a running story in the lab that was super funny. It's like there was this freshman guy, and he became involved in the lab. He, started to write code, and then someday he learned that you could name variables whatever you wanted to name.
Right.
And he started to name his burgers, his variables like hamburger or pizza or whatever. And it was super funny. Of course, you wouldn't want to do that.
Of course.
But he learned that you could name your variables anything, right? And in real software engineering, you would want your code to be readable, right? Like you want your variable to be called something that makes sense for the program that you're reading, for the domain that you're writing code for. And that ties into, right, good software engineering practices. And beyond writing code, right? Especially nowadays where Gen AI tools are going to become more and more proficient, writing code.
Mm-hmm.
So you can have a Gen AI tool give you code that compiles and runs, right?
Right.
And that's amazing. And, you'll, let's say it even goes into the hundreds of lines of code, maybe, right? And that's great. But when you're talking about enterprise level software, something that has to be maintained, understood, extended, we're talking about hundreds of thousands of lines of code. Some code bases, I think Google's has billion lines of code in the monorepo. You have to write your code and structure it in a way that it plugs in with being able to extend it, being able to maintain it, being able to in the future modify it easily and so on. So hacking up an app with snippets that ChatGPT gives you is doable. Yes, you could get an app running. You'll get it functioning potentially. I don't know. I haven't personally done it. I think you have. So
Yeah.
So it probably does work. But then the thing is, like, what happens now when your requirements change completely? And it's like you wrote an app that does XYZ. Now you need it to do ZYX.
Right.
And are you going to paste the whole app into ChatGPT again and ask it to rewrite it? You don't want to do that. Why not, right? There's potential for you to introducing bugs. There's potential for you breaking features that already existed. Like software is incremental, and it's incremental because it's designed to be incrementally buildable, to be modifiable. Right. So that's where the software engineering comes into place, right? Like I think people still debate about this, about
what it actually
developer, developer versus coder versus software engineer. I consider myself a software engineer because not only do I write code, I design systems. I design the code that I'm going to write and make it in a way that I can modify it easier, that other people can understand it, that it can plug in with other systems. So it's just more than writing the code.
That totally makes sense. There's a very famous quote. It's like we write code for other people to read it, and it just so happens that computers can understand it, right?
Exactly. And that's not only other people. Like I found code that I'm reading the code, and it's like one of those WTF moments, right? So like, what is this? Who wrote this? And then I go and look at it, and it was me. It was me 6 months ago. It's like you forget what you write, right? Like you're human. You can only keep so much context, and then as you're changing projects, you're not going to remember all the details of something that you wrote. So if you didn't write it the right way, then you're creating more. You're making a mess for you, for your company, for the next engineers that come. And when you're working as an engineer, you have a responsibility to produce high quality code, right? Because at the end of the day, you're being paid to produce a product for the company, but you have this duty to make it right, like to do it right, like just not hacking up something to get it to work because I'm gonna leave in 6 months. Like that's not the right mindset, right?
And that's a very interesting thought as well, because as the say says, Rome wasn't built in one day, right? And as you also mentioned, even code that you did 6 months ago, now it's completely different. And building on those incremental steps, it's what got you to Google, right?
Right.
And now, now moving into the experience at Google, I think this is one of the companies, it's in the FANG companies, right? That was one of the top companies. Being in the ads division must be very challenging, as this is one of the biggest products and maybe one of the core of Google. And, being in that position doesn't come without any challenges, right? And it never comes with just here's it handed. Do you have any story of any challenge that you encountered on your way to where you are right now? And how did you
Sure. I mean, I think for anyone that's somewhat familiar with the software engineering trade and the industry, you'll know that tech interviews are tough, right? Like, what do we mean by that? It's basically a tech interview is that you usually have 5 to 6 rounds of interviews. You have an intro interview that is a tech screen, is what they call it. It's like, oh, can this guy write code? Can this person write code? So that's your technical screen. Once you prove that you can write code, then you have what we call the full loop, which is 5, 6 rounds of interviews where they are completely technical. What do we mean by that? You're going to sit there for an hour with
Per interview or in total?
1 hour per interview.
Per interview, okay.
Yeah, 1 hour per interview. You have 6 of those, or I think 6 might be too much. Some places would have 4 to 5, depending on the level that you're interviewing for. You might have more, right? Because
Okay.
if you're going for a more senior position, you're probably going to get an extra round, which is going to be a design round, right? But let's say you have 4 to 5, and then each of those are going to be a question that you're expected to code, right? So I'm going to give you a problem. I'm gonna tell you something. It's usually vague because the interviewer is also looking for people to ask questions, inquire, and ask for clarification. And all of this has a reason, right? Like I see people usually complaining about the way that tech interviews are done, and it requires you to practice, it requires you to study, and all these things. And the questions don't relate completely with the job. And let me tell you something. I think that is not true at all. And the reason I think it's not true at all is because this. When I was preparing to interview, right? Like I knew how to write code. I knew I was familiar with many practices. I knew I was a good engineer. And I knew that I needed to do well in my interview. So I knew that I needed to prepare. And that means going back to studying algorithms, going back to studying data structures, going back to sometimes even relearning things because you forget them, right? When you were in school, you just maybe learned it a little bit to pass an exam, and that was it. And I spent a lot of time just relearning things and becoming a better engineer, right? Like in the process of you studying for that, you are becoming a better engineer. You're learning to optimize for things. You're learning about new algorithms that you maybe did never learned about in school. You're learning about how certain patterns work because at the end of the day, it's all pattern recognition, right? So
Technologies and so on.
yeah, how certain patterns apply to like how you can apply a given pattern to solve a given type of problem, right? So when you're doing that, you are becoming a better engineer. You're studying about systems that have already been built that are successful, that are handling internet, level traffic, billions of requests a day, and then you're becoming a better engineer. Like you're absorbing all that information, you're growing, you're learning, right?
It's education, right? It's education.
Like now in your job, when you go do your job, you know all these tools that you didn't know before. You know from experience of other people, right, what worked and didn't work for them, right? So now you have a mental map of the tools that you can use to solve certain problems. And not only that, I was at Microsoft and I was working on database internals, and there are some very interesting problems there. And for those of you who are familiar with SQL Server can give you an execution graph of how a query is going to be run, right? So let's say you have multiple tables, you want to join them, you want to filter, blah, blah. You can get SQL Server to tell you how the query plan,
the path, even before it does it.
Even before it does it, if it has statistics. As you insert and remove data, SQL Server can keep statistics and on average know how many rows you have and all these things. So it can give you an approximate plan, and then it'll give you the concrete plan once it executes it. But my point was, like, if you think about it, an execution plan is a graph, right? Like you have a graph, you have a graph of things that are happening, and it's very complex. And in general, you will have multiple plans that could depend on multiple things.
Right.
So to work in that area, you have to be familiar with graph problems. You have to know how to operate on graphs. You have to know how to traverse graphs.
What a graph is.
Right?
Right?
How to find particular nodes in a graph. So all these things that I learned while preparing for my interviews became directly relevant for my job. I needed to implement a quick visualizer for those graphs. And had I not become familiar with, with graphs and everything the way that I did prior to the job, it would have been very difficult for me to accomplish this because it just required knowledge that I did not have before. And, likewise, working at Google, I've had to apply knowledge that I acquired while preparing for interviews, right? Mainly design knowledge, right? It's like, let me look at big systems that have been built by companies like Google, by companies like Uber, by companies like Twitter, Microsoft. Let me see what worked and didn't work for them. In the industry, there is a lot of white paper publishing. So teams will publish a white paper on when they do something, when they did something, whether it worked or it didn't work.
Don't do this.
Exactly. And then you learned from it, right? Like it's like you learn from other people's experiences and now you know the types of systems that you can employ. There's also books. There's one book that I think is really good. It's called Designing Data Driven Systems or Data Intensive Applications. And it talks about many, many patterns and tools that you can employ when building data intensive applications. And at big companies, let's say that you are exposed to harder problems, if anything, just because of the scale, right? Like company like Microsoft, if you're working in Azure and you're servicing any Azure service, you're talking about you have at least thousands of customers and you have daily traffic, insane daily traffic.
Billions of requests.
Exactly.
Probably.
Same thing at Google, right? Like Google, think about how many requests Google.com handles a day, right? So, if anything, due to the scale, the types of problems that you're trying to solve are very interesting. So, I think that studying and preparing for interviews only make you a better software engineer. Is it challenging? Is it tough? Yes. You have to find the time to sit down and study. You have to have the will to actually sit there for a couple hours and absorb information. But it's just, I think, if you're passionate about the trade and the field of software engineering, then it's only gonna make it's gonna only gonna be better for your career because you're gonna become a better engineer at the end of the day, regardless of whether you end up getting a job at Google, at Meta, or whatever. You are going to be a better software engineer by learning all these things, right? And maybe you apply those things to your current job, or you find a job somewhere else and you become the subject matter expert on something because now you know all these things. It's just a matter of you wanting to study and wanting to learn. And I think that particularly with software engineering, we'll always and will always be learning something new, whether you're working front end, back end, embedded systems, whatever it is. Technology is always evolving. There's always new frameworks. There's always new and best practices. So you're always going to be learning, studying and learning something new. Like that's just the reality of it.
Right, because education is something that they can never take away from you, right? And as you said, it's something that you're learning, and it's not that you're throwing it away. At the end of the day, that's staying with you, and you never know when you'll apply it, right? But I think that the argument, and it's what you see a lot on the internet, right? Like I studied all these problems,
Yeah.
and now in my job, I'm just told like make this button bigger and blue. It's like, how am I applying all this graph stuff, right? Do you think that that is more applicable to higher positions in software rather than an entry level software engineer?
That's a good question. So I would say that everything is a process, and there's always going to be several factors. There's always going to be business need. There's always going to be a bit of luck, right? Based on the team that you end up and the team that you end up at, right? Like the job that you're doing is going to depend on the team that you're in. That's just the reality of it. There are mature teams that they have a service or product that's basically in maintenance mode. Okay. So most of the features that needed to be implemented for it are implemented. It's a very mature product has been making money for 15 years, 10 years, whatever it is. And the features that are being added are very, very small, or improvements on existing features. There's no big changes needed.
If it works, don't touch it, right? Exactly. Like if it's making money.
You know what I mean? So yes and no, because in theory and if you look at like agile practices and whatnot, you should in theory refactor your code every 5 years or so. But still, like some products are so set that there's not a lot of change that's needed. So if you get into a team like that, you are not going to be doing a lot of new features. You're not going to be doing a lot of groundbreaking work, because just there isn't any groundbreaking work to be done for that product. And it could be even a red tape politics thing where it's even hard to convince people to add features to the product, because then you risk regressions, you risk breaking features, right? So
you want to be safe.
There's always the business side of it, right? So that's going to depend on the team, right? So if on the other hand, you land on a new team building new products or building a system from scratch, then the chance for impact is very high, right? Like you are going to be able to build things from scratch. You're going to be able to shine. And of course, it's going to depend on you at that point, whether you want to put in the work, whether you want to actually contribute and do something great, right? But it depends on the team. Does it happen? Yes, that you have a really tough interview and then you end up working on something basic or simple. that does happen. I think it could be more prominent for entry level positions where you're implementing or doing tasks that other people planned,
Right.
versus you having autonomy to do things. As you progress in your career, you become the lead or the designer, right? So you start to look at systems from 10,000 feet, and you start looking at things that could be improved. We're moving data from here to here, copying it from here to there, but why, right? Like you can redesign this whole pipeline and save yourself compute, save yourself throughput, save yourself money. So you can make some of those decisions, right? And you can sell those projects to leadership. And if it gets approved, then you coordinate engineers that are going to be implementing those things, right? But
Right.
the people that are working implementing things might not have the whole scope, not because you're hiding it, but it's usually because for engineers that are starting, they're usually, or we are usually focused on the code, right? Like we want to jump into the code right away, and we want to write code quickly. And sometimes you have to take a step back and, okay, what am I writing code for? Like, let me design this first. Let me understand the problem. Let me understand what it is that I'm trying to do, and then I'll jump and write the code. But usually when we're starting, we just want to write code right away. So that's when also it becomes more of a job, right? Because now it's work. Now you have to actually think. It's not just a task that you're gonna write code for, right?
Right.
So it at the very beginning, or when you're starting out, it could be also be more fun because you're doing implementation tasks. You're like writing code, blah blah blah, and it's all very fast paced and fun. As you progress, there is probably less coding and more design, more abstract thinking, higher level thinking, and yeah, that's just the nature of it.
I guess it really depends on what you call fun, because some people might find the first approach more trivial and it's
That
like
is true.
boring to just overdo, whereas other people might be more interested in the design. It's like getting to
That is
think
true. That is
at
true.
these things at a higher
Yeah,
level.
I guess at the end of the day, it's a matter of preference.
Right.
Yeah, I personally find writing code way more fun than designing
Design and
things.
stuff. And that's very interesting, right? Because that's the job that you do now, right? That's the impactfulness and the responsibility that comes with that as well. And tech is not an easy field, right? Because as you mentioned, even just for the interview, you have to prepare. You have to do a lot of problems at work. You're probably designing, and the pressure of having millions of people using the software. How do you manage that? How do you manage that with your life? What does that work life balance look for you? And are there any tips for navigating these challenges as well for other people listening?
Right. So I think setting boundaries is important, right? Usually when we're new to a job, we want to deliver, as quickly as we can, as much as we can. But that could long term be counterproductive because you are delivering something that's unrealistic. And the reason it's unrealistic is because it's not sustainable. You cannot work 90 hours a week for the rest of your life, right? Like that's just not true. That's not going to happen. So there's always a ramp up period where you're going to be working hard, but because you're learning what you're working on. It'll usually take 6 months to a year for you to actually get your bearings and understand what you're doing and understand the team and understand the product and depending how complex it is, right? And once you are there, then you can start to do meaningful work. Like you cannot improve a system that you don't understand because you don't understand it. You don't know what's there to improve, right? Once you get past that, then your work schedule basically normalizes, right? So you can start committing your regular 40 hours a week, right? You're still going to be busy during your work hours, but you can set boundaries, right? Like I personally like to do hard work early in the morning as soon as I come into work. And the reason is that that's when I'm the sharpest, right? Like I'll have breakfast at the office, I'll grab a coffee and then sit down and what is the task that I feel like doing the least? And that's the one that I'll go do, right? Because right in the morning I'm not tired, I'm not distracted, I'm sharp, and I'll go and jump into that and quickly get it done, right? Lately I've been doing a lot of research because I'm doing a lot of design. So sometimes I have to research about something and I know it's going to be kind of boring. So I'll jump on that. Like I'll jump on doing a lot of reading. I'll jump on figuring things out, jumping my thoughts in a doc. And then once I have all the pointers of all the things that I needed to learn about, then I know I already did the grunt of the work, right? Like I already did the hard part. Now I can take my time and reread a couple of things that I already found the pointer for and polish that and turn it into a design doc, right? How do I balance it? It's trying to use work time for work, like not wasting time during the day. At big tech companies, there's a lot of opportunity for you to waste time because at the office you have game rooms and pool tables and massages and all
Massages.
these things. But personally, I usually get so busy with the work that I don't really take advantage of all those benefits per se.
Right.
So of course I'll eat at the office because if I'm at the office, I'll eat the food that's there. I think I've gotten a massage like once, and that's about it, right? Like I'm not too concerned about all those things because at the end of the day, I'm being paid to do my job, right?
So if you're sold on the massages, the free food, just know that you might not even use it every day.
Well, the food you will use, the massages probably not. Yeah, but does it help? Does it make your life easier? Yes, of course. Like not having to worry about food, like what you're gonna cook for the next day is always good. So you just come into the office and know that there will be food. Like that makes your life 100 times easier. You can focus on your work, but definitely do work during work hours. Don't waste time because then you're shooting yourself in the foot. Like if you spend the day wasting time and you still have to deliver, then you're either going to be performing poorly because you're not going to be delivering the tasks that you need to deliver, or you're going to be working nights, which probably don't want to do. So use time wisely, prioritize. Prioritize, I think, is number one. And that could take some practice, some time to learn to do is do the tasks that require, your immediate attention and defer the ones that you can defer. Learn to say no. You cannot say yes to every task. You're always going to be asked, the more work you do, the more work you're going to be given, but you cannot say yes to everything because you realistically can't do everything. So learn to say no, prioritize, and don't waste time. I think those are the best ways or the best approaches and what will allow you to have a decent work-life balance. Will there be hectic times? Yes, of course. Sometimes you're delivering on a project that's very critical for the company and for X, Y, or Z, it got a bit delayed, or there's something that didn't go according to plan. This happens all the time. We plan things and they just don't work the way we thought they would. And then you're trying to deliver still, you're in a crunch at the end of the quarter or whatever it is. And you might have a week or a couple of weeks where you pull more hours than normal. Yeah. That happens and that's understandable. But then to balance that out, there are going to be other weeks where you just work your regular 40 hours at a steady pace. There's, no one's rushing you. You're focused but relaxed. So there is a balance. There definitely is a balance. But it's up to you to drive that balance. Because if you procrastinate and defer all your tasks, then you're always going to feel like you're busy or super busy or working too many hours. Mm-hmm. So, especially at big companies, you drive your career and you decide how you spend your time. And as long as you deliver what you're committing to deliver, then nobody's going to be tracking your hours or anything like that. Yeah.
And you save yourself a lot of stress, right? Like I think it was Jeff Bezos who said that stress doesn't come from the things that you can control. It comes from the inaction on the things that you can control, exactly. Right? And it's if you're shooting yourself in the foot by not doing these things, then it's going to become more, harder as it comes. And it also applies for work from home as well, right? You have your time to work and that's why you dedicate. I think those are great tips to manage work. And you've had both experiences, right? Work from home and going to the office. Right.
Well, during the pandemic, I think we were all forced to work. I worked from home for a whole 2 years. And I think that's also when I learned about putting distractions away, like even turning off my phone or whatever it was and focusing on the task at hand. Because when you're home, it's very easy for you to want to get up and do something else.
I have to do laundry right now for some reason.
Exactly. And it's in nowadays where we have fast attention grabbing little things that like you're scrolling any app and it's moving quickly and then the next thing comes, our attention spans are becoming shorter and shorter. And for a career like software engineering, you need to be able to sit down and focus on something for an hour, a couple hours. You will take breaks, of course, because I don't think you can do something longer than like an hour and realistically be engaged, but you need to be able to spend that full hour engaged. And that requires discipline, that requires, will, and that requires that you actually want to do it and that you sit down and do it. That's for sure. Then I think the hybrid model helps because when you're at the office, you might be a bit more tense than you're at home. Like you're focused on working and all these things, and there might be a meeting and you go and come and whatever it is. And then let's say you're working from the office 3 days a week and the other 2 days from home. The days that you work from home are more relaxed. Not because you're not working, of course, but because, for example, the days that I go to the office, I have to wake up really early to shower, to get ready. And I already spent I know, an hour from the moment I woke up to the moment that I started working, maybe more than an hour because I have to get up, shower, get everything ready, commute, get to work, and all that. So the days that I stay at home, I can maybe sleep in half an hour more. Then I'll wake up, have a quick breakfast, might take a shower, might not take a shower, and then jump right into work. So I'm already more relaxed. Like I know that I don't have the stress of having to commute, of getting to the office and all those things. So I can sit down and jump into work right away. And then any breaks or anything that I take, I also know like I'm in the comfortableness of my home. So there's no having to walk to another building or anything like that. So those working from home days definitely help. So I think the hybrid model is very good for that reason. Yeah.
And it helps on the opposite way as well, like you getting out of the house and actually doing something, because a lot of people can't handle being at home
For sure.
all the
For
time,
sure.
right?
I remember when working remotely started, I'm like, I love it. I want to work remotely forever. 2 years into the pandemic, I was dying to go back to the office. I was done with being at home. I needed that social interaction, that collaboration, just going out and interacting with people. You definitely need that. Yeah.
Yeah. I think we all went there. We were like,
Yeah.
yes, this is new, and then it was like, this is not what I wanted to do. But as we get to the end here, you did mention at some point AI and how people are using AI right now to write code, and even myself, as I have on YouTube and LinkedIn and other channels, posted how you can build a whole app, simple app, with just these AI tools, with zero coding and writing in natural language. Now, looking ahead in your experience and maybe the domain right now in Google, how do you see Google shaping this future of AI in your own, in your own perspective and in your own experience, in terms of the Google products and also in the ads space, right? Like advertising
Yeah.
being such a big thing in tech.
That's interesting. So honestly, I work with privacy, so I'm not directly working with anything that's AI related per se, but I can tell you what I've seen in my perception, right? Like at least personally, AI has made me more effective because I can brainstorm with a given tool and talk about specific technical questions that would take some research, right? For example, if I'm trying to use a new API, right, that I haven't used before, I can find the API spec, and that might give me some information about the function and the parameters and what I can pass to it, maybe a little snippet example and things like that. But maybe what I'm trying to do, it's not there, like the answer is not there. And, on my regular flow, it would take me an hour, a couple hours for me to find the right links, for me to go and find the right snippets in GitHub that implemented something similar, that give me an example of what it is that I want to do. Whereas with AI tools, I can point the AI tool to the research that I've already done, have it interpret that, and also use what it knows to give me an answer to my very specific question. And that saves me so much time, right, for my day-to-day work. Now, as far as Google goes, I think Google is investing in AI. Google declared itself an AI first company in 2017, and it's been investing greatly in AI since. It just released not a couple, I think very, many products that use the new Gemini model. And that's something that's very exciting, both internally to Google and externally, because now there's a tool that can be used to, as I mentioned, drive productivity. And I cannot tell you what the product roadmap or what the products will look like, not because it's confidential and I don't want to share, but because I don't know, right? Like, and we don't know yet. Like, we don't know what we don't know. We don't know the cool things that are going to be built using Gen AI because it's so new, right? It came out as a tool. We know that it's there. We know that we can use it to do great things. Within ads, there's already initiatives, right, to make things easy for customers, right? Like things that required customers to read or to do things like that could be automated with Gen AI. And there are definitely initiatives on without going into specific, there are definitely initiatives on providing a great customer experience. If you can use Gen AI to interpret some bits of data and or summarize things for customers, and that's an amazing use case. And then as far as productivity and developer productivity, then same thing, right? Like I think the Gemini model was also trained in coding, so it can generate code, it can inspect code. And I personally think that it'll drive productivity up for those who are willing to embrace AI and use it as a tool. And it should definitely make our jobs better and should help us as another tool, right? Like, I hear fears of Gen AI replacing software engineers altogether or replacing certain jobs altogether. Could it happen to an extent? Maybe. Maybe there are some particular jobs that could be automated, but I think that it'll be actually used as a tool to make those jobs better. Not easier, because it won't make it easier, but it'll make it more efficient in that you won't have to spend hours looking for the right pointers when you can have a tool that summarizes things for you. So I think that, yeah, AI is an amazing tool, and generative AI, as it's being used, will definitely open a lot of use cases for many, many products, not only within Google, but many, many companies. As we all know, Microsoft is investing greatly in their partnership with OpenAI, and they're putting Copilot in everything. And I think that's great, right? Like, it's those are amazing features that will make everyone's lives better, right? Like, for both engineers and for users of the products that these companies provide. I think AI is an amazing tool. Yeah.
That's pretty cool. And it's, as someone said, it's AI will not replace software engineers, but it will replace software engineers that are not using AI. It's, those who use AI are the ones who are gonna pull ahead, and it's very exciting, but also has a lot of fears, right? Because as you mentioned, people might not read anymore. It's like there was a meme going around that it was like, oh, look, I can summarize this email into 3 bullet points, and then on the other end it's like, look, I can write an email from these 3 bullet points. So nobody's reading, nobody's really writing. It depends on how we use it too.
That is for sure. I think that the industry would hopefully self-regulate to some extent, right? And do responsible AI. I know that's a core tenet at several companies. It's do responsible AI, make sure that the things that you're building with AI are actually helping and improving the quality of life of people, and that you're not building something that's not right. And of course, there should be regulation by government and entities so that we also make sure that the things that are being built with AI are the right things.
Right.
I think that that's important. I don't think we are there yet, and probably in the years to come we will have more regulation, both from public entities and from groups of companies within the industry that will get together to set norms and rules and guidelines and all these things that always happen when new technologies are introduced. But I personally think that it'll be a great tool, and it'll help a lot of people. Yeah.
Definitely hope so. I hope we don't have some Terminator type of thing
Hopefully not.
anytime soon.
Yeah.
So that's great. And now here at the end, Gabe, we've talked about a lot of things, including your journey, AI, tech companies, and where you are right now in life. And, just to wrap up, what advice would you give to those aspiring to work in leading tech companies and acquire these jobs that, are high up there?
I would say, like, keep learning. Don't look at studying as a boring thing, or, oh crap, I have to study for my interviews. Look at it as an opportunity to improve your career and to improve yourself as an engineer, because this knowledge that you're absorbing is benefiting you, and it'll help you grow. It'll help you get better, no matter which company you're working at. So improve yourself, and then the jobs will come. And then the other thing is that if you're really passionate about it, the place that you work at doesn't really matter too much, right? Like, as long as you are doing work that you think is good, that you think is helpful, you're contributing to society, and you are solving interesting problems that keep you engaged in your day-to-day job, then whatever company, or not even a company, maybe it is you start something, you have a startup, or you build a product, or you build something, then that's the way to go. But for sure, keep on learning, stay humble, and just keep on growing. Never stop studying. Never become complacent and think that you know everything that's there to know. And even as you progress, and even if you do land that dream job that you thought, just keep on learning. I think that's the one thing that I can say and can have people remember. Just keep learning. Yeah.
Always stay curious. That is amazing, Gabe. Thank you very much. So just to finish up, we have, as I mentioned, Sky could not be here, but she would like to provide us with a couple rapid fire questions. I'll hit you with a question, first thing that comes up to mind. Let's go ahead and get those up and running for you right here. All right, so this is our new segment that we're doing called Rapid Questions. Ready to go, Gabe?
Let's do it.
Awesome. So, favorite programming language?
C++.
Do you code better in the morning or late at night?
In the morning.
What was your first computer?
Custom built Intel Pentium 2.
If you could work on any tech project, what would it be?
It would be something that goes to space.
Which tech leader inspires you the most?
Nah.
None. Acceptable. Coffee or tea during coding sessions?
Coffee.
What's one tech gadget you can't live without?
My phone for sure.
Any hobbies outside of technology?
Housework.
Housework. A book you recommend to our listeners?
Project Hail Mary.
Project Hail Mary. One bold tech prediction for the next decade?
In the next decade, I think that we will have. This was not so rapid. Let me think about it. Let me do an educated prediction.
Definitely.
Right? So I think we'll see a lot of investment in renewable energy just because now it's starting to pick up. It's finally starting to become a reality that crap, the world is actually not going the right way. And I think that we might see AI applied to these things. I know there were already use cases where AI is being used to analyze like weather data, and it's given very very good predictions because it can understand and have more concept, more context, or keep more context than we would. So I think that AI tools will be used for climate change prediction and potential some mitigations. Yeah.
That's exciting. Well, Gabe, thank you very much for joining us today. I wish Sky would have been here, but these questions were great. Thank you for everything. And as mentioned, stay curious and keep learning. Thank you for joining us today. Cheers.